Toothpaste is basic, which makes the mouth neutral. Next, when ant or bee sting contains methanoic acid, that we studied from the first topic in this chapter. That means the naturally occurring acid. Ant and bee sting contains methanoic acid. When an ant bite happens, we feel pain and irritation because this ant injects this acid to the skin. So when this is happened, what we could do is use a weak base like baking soda that neutralizes the acid which injected by the ant. That makes us relief from the pain. That gives us relief from the pain. These are the importance of pH in our daily life. Now moving to the next topic, which are the most important one, and sure short questions you are getting from this topic. We need to study some compounds. Among these compounds, one question should be sure. Among these compounds, one must be in your question paper. So study carefully, and very important these compounds are. The first one is NaCl, which is sodium chloride. First one is NaCl, which is sodium chloride. The sodium chloride is commonly known as common salt. This is known as common salt. The salt that we are used in our food, that we are eating regularly in food as preservatives, that is NaCl. This can be derived from seawater. NaCl is prepared from seawater. NaCl is prepared from seawater. Seawater is vaporized and NaCl is extracted. That means salt is extracted. Rock salt is mined like coal. Rock salt is mined like coal and is brown colored. The color of rock salt is brown and crystalline in shape. That means this rock salt is like crystals. What are the uses of NaCl? NaCl is used as raw materials for sodium hydroxide, washing soda, bleaching powder, etc. These are the things that we use regularly in our house. Sodium hydroxide, washing soda, bleaching powder, etc. The raw materials for preparing this is NaCl. Used in food as preservative, that we all know. In all food materials, we are adding salt. Then it is used in industries. For industrial purpose, NaCl is used. That's our first compound, NaCl, that is sodium chloride, which is known as common salt. It is derived from seawater. Rock salt is mined like a coal and brown in color, crystalline in shape. Used as a raw material for sodium hydroxide, washing soda, bleaching powder. Then used in food as preservative, used in industries. That's our first compound, NaCl. The next compound we need to study is sodium hydroxide, that is NaOH. Sodium hydroxide is commonly known as caustic soda. So, which is the compound known as caustic soda? It is sodium hydroxide, that is NaOH. The sodium hydroxide can be prepared by a process known as chloralkali process. This sodium hydroxide can be prepared by a process known as chloralkali process. This process is known as chloralkali process because the products we are getting is chlorine and alkali. That's why it is known as chloralkali process. In this process, when electricity is passed through aqueous solution of NaCl, it decomposes to form NaOH. So, through aqueous solution of NaCl, electricity is passed. Then it decomposes to give NaOH. The aqueous solution of NaCl is known as brine. The aqueous solution of NaCl is known as brine. So simply we can say that when electricity is passed through brine, it decomposes to form NaOH. The equation is 2NaCl plus 2H2O gives 2NaOH plus Cl2 plus H2. Here look, NaOH plus Cl2 plus H2. So NaOH is an alkali and plus chlorine gas is evolved. That's why the process is known as chloralkali process. So from the chlorine gas formed here, we can manufacture bleaching powder. From the chlorine gas formed here, we can manufacture bleaching powder. The chemical formula of bleaching powder is CaOCl2, that is calcium oxychloride. Formula of bleaching powder is CaOCl2, that is calcium oxychloride. The chlorine gas formed here is used for the manufacture of bleaching powder. So when this chlorine acts with a dry slacked lime, action of this chlorine gas on dry slacked lime gives bleaching powder. Action of this chlorine gas on dry slacked lime, that is CaOH, that is calcium hydroxide. Calcium hydroxide is known as slacked lime. This chlorine acts on dry slacked lime, gives bleaching powder plus water, that is CaOH twice plus Cl2 gives CaOCl2 plus H2O. Now, what are the uses of this bleaching powder? The uses of this bleaching powder are for bleaching cotton and linen in textile industries. In textile industry, for bleaching purpose, this is used. In paper industry, for bleaching wood pulp, for wood pulp bleaching in paper industry, this can be used. Next, it can be used as disinfectant of water. Then another use is can be used as an oxidizing agent. Can be used as an oxidizing agent. So what are the uses? In textile industries, in wood industries, disinfectant, then as oxidizing agents. So these are the uses of bleaching powder. So moving to the next compound, the next compound we need to study is sodium hydrogen carbonate, that is NaHCO3. Sodium hydrogen carbonate is commonly known as baking soda. Commonly known as baking soda. The preparation of sodium hydrogen carbonate, that is baking soda, is known as Solvay process. The preparation is Solvay process. In this process, sodium chloride, ammonia, carbon dioxide, and water togetherly reacts to give NH4Cl, that is ammonium chloride, plus the next is the compound that we need, NaHCO3, that is sodium hydrogen carbonate, that is the baking soda. So the preparation is Solvay process. NaCl plus H2O plus CO2 plus NH3 gives NH4Cl plus NaHCO3. When this sodium hydrogen carbonate, that is baking soda, is used for cooking, when it is heated, this NaHCO3, when it is heated, gives Na2CO3 plus H2O plus CO2. That is Na2CO3 is the sodium carbonate. So during cooking, what happens to the baking soda? When heated, it becomes Na2CO3 plus H2O plus CO2. That is sodium carbonate plus water plus carbon dioxide. Then what are the uses of this baking soda? These are used as ingredients of antacids. In antacids, they are used as ingredients. Then for preparing baking soda, so this can be used as the preparation for baking soda, that is sodium hydrogen carbonate. Baking powder plus mild edible acid gives baking soda. Then used in soda acid extinguishers. Used in soda acid extinguishers. In soda acid extinguishers, these sodium hydrogen carbonates are used. So what are the uses? These are the ingredients of antacids for preparation of baking powder used in soda acid extinguishers. These are the uses of sodium hydrogen carbonate, NaHCO3. The next compound we are going to study is washing soda. How we get washing soda? Recrystallization of sodium carbonate gives washing soda. Recrystallization of sodium carbonate gives washing soda, that is Na2CO3. This is sodium carbonate plus 10H2O. On heating gives Na2CO3, 10H2O. This is washing soda. So the preparation of washing soda is recrystallization of sodium carbonate gives washing soda, and this is the equation. What is the uses of this washing soda? This washing soda is used in the manufacture of borax. Also in glass, soap and paper industries, this is used. In domestic purpose for cleansing agent, for cleaning action, this can be used. Also for removing permanent hardness of water, washing soda can be used. So mainly 4 uses are explained now. What are the uses? First one, manufacture of borax. Second one, used in glass, soap and paper industries. Third one, in domestic purpose, used as cleansing agent or for cleaning action. Fourth one, removing permanent hardness of water. Next, what do we mean by water of crystallization? This is the fixed number of water molecules present in one formula unit of a salt. Water of crystallization is fixed number of water molecules present in one formula unit of a salt. So what does it mean? When we are considering one formula unit of a salt, then the fixed number of water molecules present in it is known as water of crystallization. So when we are considering one formula unit of salt, the number of water molecules present in it, that's a fixed number. And that fixed number of water molecules is known as water of crystallization. So what is washing soda? It is Na2CO3, 10H2O. How it can be prepared? Washing soda can be prepared by recrystallization of sodium carbonate. By recrystallization of sodium carbonate. So Na2CO3 plus 10H2O on heating gives Na2CO3, 10H2O. What are the uses? This is used in the manufacture of borax, then used in paper, glass and soap industries. Then in domestic purpose used as cleansing agent, that is for cleaning action. Then last we can say that for removing permanent hardness of water, this can be used. So then what do you mean by water of crystallization? Water of crystallization is the fixed number of water molecules present in one formula unit of water. For example, we can say that CuSO4 5H2O. CuSO4 5H2O. So here it is 5H2O. Then CaSO4 half H2O. This can also be write as an example for water of crystallization. Okay. So moving to the last compound that we are studying in this chapter. This is the last topic in this chapter, acid, base and salt. So that is plaster of Paris. On heating gypsum at 373 Kelvin, it loses water molecules and becomes calcium sulfate hemihydrate. So CaSO4 2H2O. CaSO4 2H2O is called as gypsum. When this gypsum is heated at 373 Kelvin, it loses water molecule and becomes calcium sulfate hemihydrate, that is CaSO4 half H2O. This calcium sulfate hemihydrate is known as plaster of Paris. This calcium sulfate hemihydrate is known as plaster of Paris, that is CaSO4 half H2O is known as plaster of Paris. So when this plaster of Paris is again mixed with water, it turns to gypsum, which is a hard substance, which is a hard solid mass. So CaSO4 2H2O is heated at 373 Kelvin, it becomes CaSO4 half H2O. When this CaSO4 half H2O is mixed with water plus 1 and 1 by 2 H2O, again gives CaSO4 2H2O, which is gypsum, which is a hard substance. Then what are the uses of this plaster of Paris? This can be used for making toys. This can be used for making toys. Also, this can be used for making decorative materials. For the manufacture of decorative materials, plaster of Paris can be used. For smoothing surfaces, this plaster of Paris can be used. Also, this can be used for plaster for fractured bones. Doctors use this plaster of Paris for plastering fractured bones. These are the uses of plaster of Paris. That's all about in this chapter. What we have studied in this chapter. First, we study the difference between acids and bases. Then some naturally occurring acids. Then what is the difference between dilute acid and hydrochloric, dilute acid and concentrated acid. Then the reaction of acids with metal, hydrogen carbonates, metal oxides, acids and bases reacts together. Then non-metallic oxide with base, some chemical properties of acids and bases are discussed. Then we studied about the pH values and pH ranges of acidic and basic solutions. Then pH, importance of pH in our daily life. Then we studied some important compounds, that is sodium chloride NaCl, then sodium hydrogen carbonate NaHCO3, then washing soda, sodium carbonate, that is caustic soda, then bleaching powder, and plaster of Paris. These compounds are very, very important. Among this, one compound should be asked in the exam. So that's all about in this chapter. So thank you for joining me in this section. I'm Nidishas, now signing off. We'll meet you in the next section in another class.